Hello, everybody. Thank you for joining us today. We are delighted to hold this event today here in the European Sustainable Energy Week. Today, we are going to show us in a different way how improvements can be made in energy efficiency through technological cooperation. First of us, we want to introduce ourselves. We are the ENI CBC MED. We are the European Neighborhood Instrument for cross-border cooperation in the Mediterranean. We are an EU program fostering cooperation with Mediterranean neighbors, which for the 2014-2020 period, we have funded 80 projects, 80 cooperation projects worth 209 million in 11 different priorities. And we are acting in 13 countries. 7 of them are EU member states, and 6 of them are Mediterranean partner countries. All those projects must include partners from both shores of the Mediterranean to assure a proper cooperation. And one of these priorities was energy efficiency and renewable energy applied to buildings. And why buildings? Because according to data from the European Commission, buildings in Europe are responsible of 36% of global final energy consumption and 40% of total direct and indirect CO2 emissions. So improving the energy efficiency is mandatory in the energy transition, especially in southern countries where building stock has a great room of improvement. Among those projects, 8 of them have been funded in this priority, energy efficiency. And they brought together more than 50 entities, including municipalities, local energy agencies, and universities, with more than 18 million euros invested. So today, we will show how 6 of these projects have performed cost-effective energy renovations for public buildings. We will travel to 3 different sites to witness inside, okay, live, online, what some of those projects have achieved to perform energy renovations. We will also hear the testimonial of a young researcher on career opportunities in the energy sector, since we are in the European Year of Youth. And based on what we've seen, we will discuss some policy recommendations for a greener buildings in the future. Today, we are holding this event in collaboration with the Global Alliance for Building and Construction, which is the leading global platform for governments, private sector, civil society research, and intergovernmental organizations commit to achieve a zero-emission efficient and resilient buildings on the construction sector. With 250 members, including national governments, they are a big player, and we are glad to have today here Andrea Voigt from Danfoss, which is an energy company providing energy efficiency solutions, which is member from the Global ABC. Thank you, Andrea. Good morning.
Thank you very much. Does that work? Seems so, yeah.
Thank you very much, Alejandro. Thank you for the introduction, and it's a pleasure to be here and to be here in person. It's really energizing and vitalizing to see people once again in 3D and not in 2D anymore. It's also great to have such a big topic, the energy efficiency, which is really right now, I think, more important and more relevant than ever. And the beauty of this project now is to really showcase how this can work in action. Energy efficiency on the one hand side, renewables on the other hand side. No competition by any means, but really 2 solutions that must complement each other if we want to really achieve this big challenge that we have ahead of us, which includes both getting carbon neutral according to our climate law in Europe, reducing by 55% the greenhouse gas emissions by 2030, but also, and importantly, guaranteeing energy security for everybody in Europe, for all of the citizens. So I think this is a great opportunity, and I'm very happy to be here on behalf of the Global ABC, and also on behalf of Danfoss Climate Solutions, where I'm heading Global Public Affairs. So welcome everybody again, and with this I will hand over to Nora Steurer from the Global ABC, who will take us through the latest the latest findings from the flagship report that Global ABC is doing about buildings, the so-called Building Status Report. Nora is a program officer at the United Nations Environment Program. She's based in Jordan, so she's not here with us in person, but here with us on the screen, and I see her smiling. So with this, I would hand over to Nora and look forward to hearing about the latest findings related to buildings. Nora, the floor is yours.
Wonderful. Thank you so much, Andrea. Thank you, everyone. It's a real pleasure to be with you. Unfortunately for me, in 2D, not in 3D, even though I would really love to be there. As Andrea said, it's a real pleasure to do this event together with Danfoss, together with all of you at this European Sustainable Energy Week. And what I would like to do is provide a little bit of a global framing, some global facts and figures. Some of you may already be well aware of those, just to provide a sort of framework for the exciting projects that we will hear afterwards. And indeed, it comes from our Global Status Report for Buildings and Construction, the 2021 version. Note that we will shortly release the 2022 iteration on the 2nd of November, so I cannot yet share the data from that, but do stay tuned. If you're keen to learn more, you're very welcome to also attend the launch event. I'll give you more information later. So without further ado, if you could start the presentation for me, and then I will take you through those facts and figures. Thank you. Good. I can only see it half, but I think we'll make do. Okay, you can go straight to the next slide, please. Thank you. Okay, so why buildings? And Alejandro already alluded to it. And as I said, I'm sure many of you or most of you are already convinced of the need to work on our buildings now more than ever, as Andrea also said, with the energy crisis, with soaring prices. There really is the question, why not why? Nevertheless, adding the global perspective to the European one, we know that approximately every 5 days another Paris is constructed in terms of floor area. So I always like to use Paris because actually I am based in Paris. I'm back from Jordan. And Paris is a wonderful, wonderful city, as those of you who know it know. But it really shows the magnitude of the challenge, but also of the opportunity. Half of the buildings standing by 2050, 2060, depending on the model you're using, have not yet been built. So we have the opportunity to get it right. And it really is one of the most cost-effective solutions, but also one of the ones with most job creation potential. Next slide, please. And this is to this point, we know that for energy efficiency investment into buildings and construction, actually 9 to 30 jobs are created for every $1 million invested. And that's massive. It's actually much more than many of the other sectors that you could invest in with either energy efficiency or renewables. And 60% of home retrofits in Europe, of this expenditure actually goes towards labor. So there really is also this job effect, this employment effect, also very important in times of economic volatility to be made here. Next slide, please. I'll go through this quickly because Alejandro said it so well already. This is just to give you context of the Global ABC. We are hosted by UNEP. You can see it from our background, and we really have this aim of bringing the buildings sector to the forefront and putting it on the spot when it comes to climate action, for which obviously energy is paramount. So if you're keen to join, do contact us. Next slide, please. And if we just go a little bit, we heard about the massive impact in terms of floor area growth, in terms of economic potential. So what do we want in terms of emission reduction? So for the Global ABC, we form part of this Marrakesh Partnership for Global Climate Action. I know it's a mouthful, but basically it's a forum that assembles all the ones that are not countries, if we will, and together we formed a pathway that is much more comprehensive than what you see here. But the emissions reduction goal globally for buildings is that by 2030, we need to have emissions and we need to have 100% of zero carbon in operation. So this is obviously energy. And by 2050, we must decarbonize along the life cycle. So energy is paramount, but let's not forget that for full decarbonization, we need that life cycle perspective, and we need those goals to be Paris aligned. Next slide, please. So now I would like to just talk to you. These are our activities, and I won't say much more about this besides that we do track progress, as Andrea has said, through our global status report for buildings and construction, and we support countries through building decarbonization roadmaps. I want to give you a snapshot of the global status report for buildings and construction, some more facts and figures. Next slide, please. This is a graph that we did last year, and we find that it got quite a lot of attention because it compares the years 2015 when we were founded, the Global ABC, and also it was when COP21 happened, so Paris Agreement, and 2020. And I think what's important to see here is we do see progress. So let's not forget that we do see progress. There is a massive challenge, a massive opportunity, all very, very true, but we do see progress. And I think it's important to remember that, to know that we have things that do work. We see a massive increase in terms of countries that include buildings in their NDCs, nationally determined contributions, a massive increase in terms of countries who now have building energy codes. Whether they're mandatory or not is another question. We also see a massive increase in terms of investment, almost 40%. It's not enough, but we are making progress. Next slide, please. But there is another big but in my mind, which is we are making progress. The direction maybe is right, but the speed is not. And what you see here is like this little, on the left-hand side, the graph where it looks to me at least like a snake that's rearing its head. You see the zero carbon goal by 2050 we need. And then the little snake is basically, where are we now? And then we zoom in and we see in 2020, it actually looks as though we are on track. But that is because of COVID. So let's not forget, we had a very strange year. That is now behind us, although maybe COVID is not yet. And if we calculate out the COVID effects, the fact that a lot of construction projects were on hold, we are actually not on track. We're really not seeing the speed that we need. The gap between the zero pathway by 2050 and where we would need to be on track, this gap is widening. So we need to be a lot faster. We need to see a lot more of that progress that I just mentioned. Next slide, please. So this is a snapshot on building codes, and I mentioned them earlier. Obviously, there is a massive amount of regulation that we need to see globally and in Europe, and I won't say everything because it's a complex issue, as we are all well aware. Just on codes, I mentioned earlier, we see a massive increase. That is very, very good. But if we take a little bit of a closer look and we distinguish between voluntary codes and mandatory codes, there is a lot of work to be done. Only a minority of countries have mandatory building energy codes for all buildings, residential and commercial, in place. It's between 20 and 30%. It's really a minority. It's better in some regions. In Europe, you can see most of them are mandatory. In MENA as well, not most, it's 44%, but it's better than the global average. In Africa, where most of the future construction will actually take place, it's only 9%. So we have a massive, massive need to scale up this fundamental pillar of regulation. Next slide. So after this gloomy message, a message of hope, again, nationally determined contributions, actually we see that energy efficiency improvement in buildings is the most popular measure in NDCs after renewable energy. We're alluding to Andrea's point, they need to be complementary, not being in competition, but it's a hopeful message that this is really, it is getting more and more on the forefront, this issue. Next slide. And now I will talk to you just a tiny bit about the roadmaps that we're doing with countries. So you can go straight to the next slide, please. Thank you. So at the Global ABC, we're also working directly with countries and really with the ministries. We do not just want to do something that then sits in the drawer and is not being used. These are all really happening with and through relevant ministries on roadmaps. And we have developed these with input from over 700 stakeholders globally, with 8 categories to really say it's not just about the building, it's about the building in its context. So we need to have goals and priority policy and technology measures met. in all of these 8 categories: urban planning, new buildings, existing buildings, operations, appliances, materials, resilience, and clean energy, to have a truly sustainable buildings and construction sector. And yeah, as I said, we have priority measures for 2030 and 2050 and all of those. And if you go to the next slide, please. After having done regional roadmaps for Asia, Africa, and Latin America, completely recognizing the diversity of these vast regions, we're now breaking these down to the national and sub-national level. And we are very pleased that a lot of our members are taking these and they're starting to just run with it, a little bit like a franchise, if you will. These are in the public domain. Anyone can use this model. So for example, the United Arab Emirates, they're now using our model to develop building decarbonization roadmaps for 22 jurisdictions in the Arab League. And we're seeing this take up more and more. You can see here the little pillars in regions where these roadmaps are happening. As I said, always with and through relevant ministries and jurisdictions. And with that, you go to the next slide, please. That's my final one. With that, I'll stop. This just gave you a snapshot. Of course, there's many, many more points to be made, and I'm so excited to hear of the fantastic projects in the Mediterranean regions following this. I really would like to thank you for listening. If you'd like to find out more, do visit globalabc.org. You can join us very easily. We welcome new members, and you can contact us at global.abc@un.org. Thank you very much. Back over to you, Andrea and Alejandro.
Thank you so much, Nora, for this introduction. I think there is no better way to set the scene than with the status report and with the great work that Global ABC is doing. But what is even more exciting is that we will now really go to the substance of things and hear 5 very successful stories on how energy efficiency and renewables are being put in practice in the Mediterranean region. It's great to have you all here, and it's great to hear really first-hand experience from your different projects. The first speaker, if I'm not mistaken, will be Lucia Ramirez, who is an architect at the Valencia Institute of Buildings. And she will put the focus on the so-called BEEP project, which is all about building information management systems in energy efficiency in the public sector. And just to say the beauty of what you're going to hear is that each of those projects will zoom in on another aspect. So you'll really get a very global overview of what can be done in terms of making our buildings resilient and efficient. Floor is yours, Lucia.
So thank you, Andrea. I will try to, okay. Just to give you an overview of the project, the BEEP project is Beam for Energy Efficiency in the Public Sector, and it's dealing with with energy retrofitting of public heritage buildings. The main result of our project, I don't know if the main result of our project has been the development of a methodology for public administration, who is usually the manager or owner of these type of buildings, and is based on 2 concepts that I will explain: building information modeling and energy performance contracting. Right now, what you're looking at in the background is a public heritage building, and it's building information modeling. This methodology allows to centralize in a single digital model all the information of a building, and it's strange because until recently this methodology was only used for new buildings. But however, heritage buildings are far more complex and include much more extensive and comprehensive data. And this is why the application of BEAM to heritage buildings, which is the so-called heritage building information modeling, is a breakthrough. So the traditional BEAM model has been the 3-dimensional geometric model of a building, but the evolution of the BEAM methodology has made it possible to include new dimensions, and a BIM model can now include information on time, cost, environmental, and maintenance information. A model including all this data, in the case of a heritage model, is called Energy Efficiency Heritage BIM model. And the purpose of this model is to act as a kind of a repository, centralizing all the information of the building, and it should become a kind of an upgraded model with all the energy information of the building, with the goal to show how energy retrofitting measures work in this building. So, this upgraded model aims to become the tool to be used for the management and realization of energy retrofitting. And in fact, the left diagram shows the BIM project workflow and how this model becomes a central tool to be used for the financial plan and the design of the energy retrofitting interventions. Well, in fact, the BIM project has not only paved the way for BIM methodology being used in heritage buildings, but also for energy performance contracting. Through this financial mechanism, the renovation expenses are expected to be covered by the energy savings achieved, and they should be estimated prior through this central model prior to the renovation. Well, in fact, as you have seen before, the process of creating a BIM model, including historical information, energy analysis information, and financial data, is quite complex. And that's why the BIM project has aimed to summarize in a synthetic and comprehensive way this process, including all the steps to be followed by the technicians in an easy and understandable way, to make the process understandable for everybody. So the guide developed is one of the main results obtained in the BIM project and brings together the results of 3 years of work. And it presents a workflow which goes from the building analysis, the energy analysis, the design of the interventions, and the whole intervention, including the financial part. This guide is available for free download. You will see the link in the next slide. And the main goal of this project is to enhance the capacity of the public administration when it comes to renovating their public heritage buildings. So here, you can see that furthermore, this methodology has already been tested in 9 pilot buildings located in 7 different Mediterranean countries. In fact, also, it has been quite successful, and the results, also this guide, will be replicated in other Mediterranean regions through another project, also from the ENI CBC MED program, which is called the CCAP for SDG program project. So this is a little bit the motivation, and which Alejandro already explained. And by way of farewell, and since I'm speaking about buildings, I will explain you a bit about my organization, which is the Instituto Valenciano de la Edificación. And we are working as the innovation agency for our regional government. And we are approaching the building sector from multiple perspectives. So in case you're interested, I invite you to visit our website. And thank you for your attention. That's all.
Thank you. Yes, thank you very much, Lucia, for taking us to public heritage buildings, a very important aspect, and showing also the power of digital and what can be achieved with the right programs in place. So with this, I hand over to Gianni Celli, who takes us to Italy, University of Cagliari, I don't
Not Calgary, it's in Canada.
Who will speak about, who will take us a little bit more into the renewable energy side of things, and will tell us about the Berlin project, although this is not in Berlin.
No, the acronym is of the title of the project is not related to the exact title, that is cost-effective rehabilitation of public buildings into smart and resilient nanogrids using storage. So the motivation has been already said by Alejandro and Nora presentations. So the building sector is a high energy consuming. So it has an enormous efficiency potential to be attacked. So in order to achieve this goal, we test as a solution the application of nanogrid concept to public buildings in order to build some pilots projects, some pilots installations in different countries and test these solutions in order to understand also the replicability in different situations. The concept of the pilot is quite easy. In the building, we integrate some devices like photovoltaic plants, typically on the rooftop of the building, battery storage, install the automation for the management of loads, and all these devices, together with some measurements installation for weather and for ambient control, are received by a central energy management systems that have to manage all the resources, understand the status of the building, and control the charging and discharging phases of the battery, and eventually also manage the load of the building, for the goal to increase the self-consumption, so increase efficiency and reduce the bill of the building. As said, we are preparing 6 pilots installation in 4 countries, from Italy to Greece to Cyprus and to Israel. The building are, in our case, from the Cagliari University, is a building of the campus. For Israel, there are 2 schools. From Greece, we have the dormitory of the campus and a building of the town hall, and also the research center at the University of Cyprus. Here you see the pictures from the installation. We are finalizing the installation in this month. We had some delays due to the procurement of the devices due to the COVID pandemic. For instance, in our case, to have the availability of the battery, we had to wait 8 months from the closing of the tender, for instance. So there is some delays about that, but I think that by the end of the year, so the pilots are started to run, and in the next year we can show exactly the numbers and the results of this project. On parallel to this pilot installation, we're also developing some supporting tools in order to clearly to make easier the application of these solutions, and to show and demonstrate the efficiency, the effectiveness of these solutions, and help the installation. Now is already available a first tool that is an online software for sizing PV and BESS, so photovoltaics and storage, that take into account also the control of the demand, and also the different kind of local tariff, energy tariffs, and weather conditions, in order to design in the better way this kind of solutions. Other tools, other applications like policymaker tools or guidelines will be produced in the next months. So I think that I'd stay in this 5 minutes, and that's all for me.
That is in itself an achievement. Thank you. Thank you very much, Gianni. So much about the building itself as well. The building itself acting as really a self-sufficient entity nearly, and that also shows the power that we have in improving things there. So now traveling to Greece, to Marina Kauta, who is engineer at the University of Patras. and who will tell us everything about the green building project, yet another angle to buildings. Marina.
Not everything in 5 minutes, but I'll try to say some tips and highlights. Okay. Let's start. Andrea introduced me, so I will move on. Our project aims at reducing energy consumption and adverse environmental impact by using renewable energy sources and energy efficiency measures in public buildings, since renewable energies represent a natural competitive advantage for the Mediterranean area. The project plans and supports 3 cost-effective energy renovations of public buildings across climatic zones in Greece, Tunisia, and Jordan, while monitoring the effectiveness of renovation using energy measuring devices. Greek pilot is a regional building in Sparta. The Jordan pilot is the building of the Greater Irbid municipality, and the Tunisian pilot is a hospital building. Now, 2 out of the 3 pilots are in the final stage of the renovation procedure. I will not go in further details with the energy renovations, but I have collected some best practices from our experiences so far, thus resulting in 5 items which should not be missed when preparing a public building renovation. The first one is to build consciences by involving users in all renovation phases, pre-renovation, the renovation stage, and post-renovation, and train the users and the general public in energy efficiency measures. The second one is to use key performance indicators for optimizing energy performance, including not only conventional indicators, but also KPIs for renewable energy sources, for example, green factor, which is the fraction of energy used for renewable energy sources divided to the total energy consumption, and other users' comfort indicators, etc. The third one is to record the energy behavior and profiles of the building users with the use of questionnaires and interviews. This is critical since users significantly influence the final energy consumption of a public building. A unified protocol for recording the habits of building users should be developed to estimate the type of users, high energy, medium energy, low energy consumers, and to adapt the next phase, which is the educate and train phase. The fourth one is to define the energy upgrade scenarios, which includes the definition of the renovation type and scenarios to be examined for public buildings. And finally, the fifth one is the development or adoption of an energy management system to monitor and control the building's energy needs. Sorry. Okay. But what is our plan for the engagement of building users? First of all, we involved building users from the pre-renovation stage when we developed the energy studies. In total, 609 respondents participated in the survey. 1 survey has been conducted per pilot site, and in their vast majority, they agree that sharing the amount of energy consumption with employees is important for saving energy. During the renovation phase, we produced 2 videos on what to do to reduce energy consumption in the office building where they work, and the role of the e-tool for energy monitoring in the energy consumption reduction, and we informed users on the renovation actions. Finally, since our goal is to enhance and promote an ecological use of public buildings, abiding by their traditional use and role in the community, 6 trainings are going to take place after the renovation actions in the post-renovation stage. Among others, the building users will be trained in the use of the e-tool, which will allow the interconnection with the energy measuring devices of the pilot buildings, and will be used for the monitoring of the energy consumption of the buildings and for sharing messages for increasing the energy gains. The e-tool will allow access to the building users to monitor energy flows, energy consumption, and demand and supply of energy, because all pilots are using photovoltaics as a renewable energy source. It will also facilitate building users' acceptance and commitment. It is expected to reduce energy consumption and energy costs, and to facilitate the decision-making process for the energy intervention measures in the buildings. Finally, the visualization of comparison analysis through charts will allow the certification and validation of savings in an objective way and make the energy management process even more comprehensive to the building users. Finally, our motto is to embrace user involvement in all phases of the renovation project. Thank you all for listening and for your attention. Thank you.
I think the timing was perfect. Thank you. So yet again, another aspect and the importance of also involving the users, because they, at the end of the day, are occupants of the buildings, and if they are not convinced and cannot contribute, then many of the things fall apart. We also heard about the importance of having energy management systems in place that can very much contribute in this sense. So with this, we are now going to Rosa Schina, who is project manager at the National Association of Italian Municipalities in Tuscany. So yet another of those beautiful Mediterranean countries, and who will tell us about the SOLE project. The floor is yours, and if you could also stick to the time, that would just be perfect. Thank you.
Thank you, Andrea and Alejandro, for this opportunity. SOLE project supports cost-effective and innovative energy rehabilitation of 7 different public buildings in Mediterranean area. Beside these pilots, in order to reduce building energy consumption, SOLE will also intervene at 2 other levels. First, by encouraging behavioral change in people through at-green campaign. Secondly, by impacting on local policy through lobbying and advocacy to integrate the pilot's results in relevant policy frameworks. My presentation will focus on capitalization process inside SOLE project. Next slide, please. Through its capitalization activities, SOLE will seek to influence policymakers in charge of the energy sector at 2 different levels. Local level and wider level, so Mediterranean or European level. Next slide, please. The continuous capitalization process will be achieved through structured activities facilitating the efforts of policy and decision makers to address the problem on environmental impact of building energy uses and to achieve compliance with relevant regulations. Next slide, please. As already said, capitalization is structured into 2 main streams of activities. SOLE want to impact on policy at local level. In each country, partners create a policy working group with key local stakeholders. Then SOLE project want also to impact at wider level, integrating SOLE results into cross-border recommendation. This work is designed to deliver a strategic vision, designed to influence all major decisions concerning green building rehabilitation. As with local policy impact, this is achieved through a cross-border stakeholder group and 2 large capitalization workshops. Next slide, please. At this stage of the project, we have prepared 1 report per each project area. We have 7 different countries that agree to participate to SOLE project, and 7 different reports has been produced in order to make a clear picture of the main key aspect related to energy requalification of buildings, of public buildings policy at local level. Next slide, please. I try to summarize the main results of this analysis. As also other speakers said before me, the energy situation in the Mediterranean area is critical, considering that the countries facing the Med are characterized by an old building heritage. Lack of intervention over time have led to high summer and winter energy needs in building, increasing annual energy consumption and carbon dioxide emissions. By the other side, the Mediterranean area is characterized by culture and construction methods, and thanks to geographical position, there is a strong potential in the use of renewable energy resources. The main local policies in Mediterranean countries has 2 different types of scope in order to reach the goals related to the reduction of carbon dioxide emissions. First, encouraging the uptake of alternative resource of energy from fossil fuels, so for example, renewable resources. Secondly, by reducing energy consumption, for example, stimulating through economic incentives the installation of more efficient conditioning system and the thermal insulation of buildings. Next slide, please. The COVID-19 has had a tremendous impact in the delays of the work on related to energy requalification of buildings, and also the war in Europe is rising the prices of raw materials. The lack of supply of natural gas to Europe from Russia have stimulated all Mediterranean countries to work on energy efficiency, especially in public and government buildings. Most of the central government of Mediterranean countries has established countermeasures to gas crisis in order to reduce energy consumption. For example, limiting the temperature and hours that in public of energy consumption in public and government buildings, limiting the time of shopping malls, reduce the public lighting in streets. In case we have two different types of situation in Mediterranean. For example, there are countries like Egypt, where there is a surplus of natural gas, and all the above measures are in order to reduce the amount of natural gas used in power generation plant in order to export this gas to Europe. On the other side, there are countries like Italy, where the energy reduction, the gas energy consumption are related to the fear that there is not enough gas for the winter season. So that's next slide, please. That's all for my presentation. Please find out more about Sole Project on our social channel and also on our website. Thank you for the attention. And again, Alejandro and Andrea for this opportunity. Thank you so much.
Thank you very much, Rosa, for taking us through your project. A very lively presentation of what you're doing from an Italian perspective, and that brings us to the last success story in this round, where we will have Osama Sadeh, who is associate professor at the German Jordanian University, who will tell us about the ESMES project. And there, if I'm not mistaken, schools will be in the center and play a very important role. So I hope he'll show up on the screen in a minute. Osama, the floor would be yours.
Good morning, everybody.
Good morning. We hear you, but we don't see you for now. Ah, there you are. Perfect.
Good morning, everybody. So I'm going to be talking today about the design of customized PV systems, what we call data-driven PV systems for buildings that have what we call nonlinear loads. It's a new way of designing PV systems. This is one of the activities of the ESMES project, which is the energy, I don't see the slides. Can you guys see the slides? Are they up? Yes. So this is part of the activities of the Energy Smart Mediterranean School Networks. Next slide, please. So what is the need for data-driven PV system designs? Over the last decade, there has been tremendous growth in renewable energy penetration on electrical grids around the globe. And the traditional way of designing these PV systems, which relies only on annual energy demands and averages, is causing major power quality issues to the power generating companies and the power system operators. As you can see in these two figures, the way we consume energy is very, very dynamic. It changes within, over the whole day. The top figures show how it's changing over an hour, and the bottom figures showing how it's changing dramatically. So we have to take these in consideration when we're designing our renewable energy systems to not be a burden on the national grids that we have. Next slide, please. So one of the solutions for this is when designing a PV system, not designing it as its own entity, but designing it with the power grid in mind. And when we're doing that, what we're doing is we're designing the PV system with what we call power quality equipment at the same time, keeping in mind how the load is dynamically changing. This requires that we understand the connected load we have, which requires detailed load characterization. With the ESMIS project in the 5 countries, we're working with 34 different schools. And what we want to do is measure those different characteristics of these different schools and then choose a subset of those schools where we actually do our pilot programs. And next slide, please. So what we did is we installed what we're calling an online platform. And what this is a server that has the appropriate software to gather information from those 34 different schools in the 5 different countries. We're gathering that information about energy consumption, about power quality, about energy, about current, voltage, all these different characteristics that tell us how the energy is being used at those schools. And the system generates reports that shows us how this consumption is changing. And we're using those results down the road. We'll talk about it in a second. So can you go to the next slide, please? So this is a sample of the data acquisition systems that we've been able to install at these different schools, at the 34 different schools. If you look at the figure on the left, you can see the addition that the system that we have. This is the data acquisition system. You can see on the front of the panel, this is what we're calling the power analyzer, and you can see the wires going to the panel on the figure on the right. So it's going to the school's electrical power system, and we're measuring current, voltage, all these different things locally. We're processing that data locally. We're storing that data locally, and then we're forwarding that data to the online platform where all the partner researchers and the partner institutes can have access to that data. So we are getting all this detailed data, and we've actually been able to share this data with some of the stakeholders in the different countries through what we're calling our national energy hubs. And even the electric companies are surprised at how much details we have, which is typically not available even to the electric companies. Next slide, please. So we're taking that data, and part of the ESMIS activities is actually using that data to do the data-driven design that we talked about. So we took that data, and you can see in the figure in the middle, we're using that to design what we're calling an optimized PV system. And what this optimized PV system is we're looking at sizing the PV system to be in harmony with the other equipment we have, which are the power quality equipment, such as the voltage regulators, the storage systems, the power factor correction. And we're doing this to have a better integration of all these different equipment at these public schools. So instead of having just a PV system that's generating during the day, but it's affecting the power quality, and that could turn off sometimes when you have these nonlinear loads. And we're talking about vocational schools where we have these nonlinear loads that act very differently than what we would typically see in a residential building. We come up with this really nice figure that shows us how we zoom in to an accurate PV system size. That's an optimized PV system size. And this optimization tool is also part of our activities at ESMIS. We've completed the PV system design phase, and now we've started with infrastructure work. So you can see the figure on the left is part of the infrastructure work that we're adding to these schools to be able to better receive the renewable energy systems that we're installing. So we've already started, based on the work that we did with the data-driven systems, are upgrading the schools to be able to accept the PV systems that we're dealing with. And the picture on the right is showing you one of the schools that we're working with. And that's all for me.
Thank you. Thank you very much, Osama. And that was the fifth of this first round of success stories. I think what we all heard very loud and clear is the importance of data and also the power of digital solutions, data management systems, whether this is about monitoring, understanding what's going on in a building, influencing the behavior also of the occupants of the buildings, and also dealing with fluctuating and intermittent renewables. So I think really a very good overview of what can be done and what can be achieved. We are a tiny little bit behind schedule, but it's still manageable, I would say. So I would, before handing over to the next round of success stories, I would like to take the opportunity of this combined knowledge of all of you working on those projects and ask you a question, which is, you have all worked with public authorities, different types of public authorities throughout this topic. Working with public authorities is sometimes a challenge and comes also with specific requirements and specific ways of working. So my question to you would be, how did you convince the public authorities to go ahead with the renovations, with the various renovation ideas and models that you tackled? What was it? What was the magic thing that really kicked it off and got them on board? Floor is yours. I don't know who wants to jump in first. And maybe we have a cultural difference there as well between the different regions in the world.
Maybe just a word, taking the presentation of the project of Marina. Training. You have to train personnel of the public authority just to not be worried about the news.
I think certainly makes sense.
It's a key step.
Yeah.
Otherwise, it's difficult to talk. It's difficult to make them understand the benefits you can achieve with different kind of solutions.
Communication, training, awareness raising. That's certainly true.
Yeah, as you can understand, for us is the same. The point is to show them which is the difference between the do-nothing scenario, different scenarios with the use of indicators or whatever, and also to show them best cases, especially when the cases are similar to their own buildings, the buildings that they are managing. Then I think that this is the best solution to convince anyone to be part in this process, to take part in this process.
Yeah, I guess that's even true for, I mean, that's true for any authority and any even private sector entities, training, education, explaining how does it work.
And in our case, I agree with Gianni and with Marina. I think the best way to combine them is by showing them results. And also they need to be provided with tools, because sometimes there's like the main barrier to face some challenges, at least in our case.
Yeah, right. I don't know if the people who spoke on the screen, if they can chip in as well. Do you know that, Alejandro?
Enter, I don't know.
Ah, Rosa can intervene, I'm being told. So, Rosa.
I agree with other speakers. I think one of the best ways communication is showing similar cases related to the one where we want to intervene. I think also that even more in this historical moment, the main leverages for energy rehabilitation of public buildings are related to economic incentives and the prospect of reduced energy costs over time through energy efficiency. Even more stimulating the installation of energy monitoring system can be a great support. Significant energy savings can really be achieved by simply having full knowledge of what the usage partners of the building.
Thank you, Rosa. And I'm being told Osama also would like to intervene. Osama?
One of the things I think is very important, understanding, or actually conveying the message to these different government organizations that this is actually, there is no downside, it's all upside. So with these systems, energy efficient, renewable energy, first, it is actually very, very, very efficient system that is very good for the environment. At the same time, you have a lot of benefits financially. So a lot of these solutions, you know, you're doing something good for the environment, but it's costing a lot of money. The payback period is very long. It's not the case here. Here we have these solutions that have very good return on investment, very fast, investment recovery times, and at the same time, it's good for environment. So the big issue is a lot of these government organizations think it's too good to be true. So that's why it's very important to convey the message that it's not too good to be true. It's actually a very good solution that has no downside to it. So I think conveying that message is one of the major ways that we get people involved and get people on board of what we're suggesting.
Right. Thank you very much for those insights. And I think also explaining that there are significant savings over the lifetime and the running of equipment and during the operational phase, even if there may be a capex in the beginning. So also this conflict we sometimes see. Okay. So I think the takeaway here is you all did great jobs in this convincing, theme. It's about information, it's about awareness raising, it's about training, and it's about using tools also to show the benefits that can result from it, and also the savings that can result from it. And then I'm told that it's Antonella's video afterwards, and I hand over to Alejandro.
Thank you very much. Thanks to you all. So far, we've seen 5 projects and how they did, but we told you that we will show you 6 projects. So we are going with the next one, in which we are going to travel to different sites. This 6th project is the Med-EcoSuRe project, whose aim is to enable a cost-effective renovation within university buildings. So they have done renovation in 3 different sites where we are going to travel right now. And we will start with Italy. We will meet Antonella Trombadore, who is professor of environmental design at the University of Florence. She holds a PhD as architect, and she's specialized in the fields of sustainable architecture, responsive design, green architecture for resilient cities. Unfortunately, apparently there is a problem with the connection, but we have a backup video so we can see what they are doing. So we are going to travel to Florence, to the main cluster of the historical building of Santa Veridana, which was built as a convent in the 14th century, and nowadays is the School of Architecture. So if we can launch the video.
Welcome to the Med-EcoSuRe pilot site in the School of Architecture of the University of Florence. We are in the main cloister of the historical building complex of Santa Verdiana, built since the 14th century in the heart of the UNESCO city center. This block was being selected as pilot for the energy renovation action in the framework of the Med-EcoSuRe project. Here, a living lab has been set up to experiment with an innovative and eco-sustainable renovation process. The name BICS Lab, Building Environmental Experience, underline the centrality of human behavior as well as the key role of people and their experience inside the building. The Living Lab helps to bridge the gap between stakeholder and end user, stimulating a positive dialogue to produce innovation. For this reason, we are engaging academics with experience in different fields, and above all, the students. The focus is on development of digital twins by combining building information modeling and real-time and dynamic environmental data that influences indoor comfort thanks to a continuous monitoring system. Pending from the ceiling, you can see temperature and humidity sensor and globometers. On the wall, sensor of lighting level, sensor of CO2 levels, flux meters to measure the thermal flux across the envelope elements, both opaque and transparent. We are also connecting external site-specific environmental data from a weather station. Moreover, we are also collecting qualitative data and end-user feedback with an online questionnaire on the perception of indoor comfort to be combined with prediction of simulation and monitoring output in order to enrich the digital twin. You can also see the IoT LED system. It was the first installment of energy renovation project. We decided to install a large number of lighting and monitoring devices to explore different use scenarios. Every 5 seconds, environmental data recorded on a server. It is possible to have a first visualization using an open platform. On the left, you can see the graphic representation of the daily data related to the different environmental parameters. And on the right, you can explore the BIM model. In the framework of the participation of our university to the New European Bauhaus program, the last year we organized an international workshop engaging architectural students in the co-design of several renovation scenarios by exploring the build model for the simulation of the energy performance. Now, the final scenario is under realization. It foresees the addition of a tridimensional structure to protect the south facade, to control the solar radiation, optimizing shading and daylighting inside the room. Also producing renewable energy, integrating innovative amorphous silicon photovoltaic panels. The future activities in the Living Lab are addressed to develop an user-friendly platform, not only for the visualization, but also to stimulate the interaction for both facility manager and end user. In this way, it will be possible to augment the awareness of the people on energy efficiency in building, stimulating more proactive behavior for well-being in the university spaces.
Thank you. I think that we can still talk with Antonella for a while. So we saw your video. Hello, Antonella. We managed to see the video, but we couldn't see the make the visit online. So I wanted to ask you one question, because you talk about a digital twin, and I would like you to explain us what a digital twin is.
Thank you, Alex, for the question. The digital twin is based on a virtual model of the building, created by BIM. So it is a methodology to create a virtual space of this. But also it's very important to implement this model with the real-time and dynamic data collected by many sensors and IoT. In this way, it is really possible to realize a completed, a very rich picture of the building, not only reproducing the energy environmental performance of the envelope and of the building, but also valorizing the role of the people, introducing many data coming from the feedback of the people inside, and many data come from the experience of them in the living space, integrating their perception of indoor comfort and also engaging the end user, the student, and the other researcher toward awareness for the real view and approach of sustainability and implementing their proactive behavior. So the digital twin will allow us to create a very interaction between the physical space, the living space, and of course, the feeling of the people.
Okay. Thank you very much.
Thank you,
so
Leandro.
we know how important it is to gather data if we want to foresee what our renovations will bear if we do them. So our next stop is in Tunisia, and we're going to meet Afef Abdelghani Bennani, who is Associate Professor of the National Institute of Applied Sciences. Yeah, okay. Of Applied Sciences and Technology. Her research interests include fault-tolerant power systems, multi-level converters, and power electronics for renewable energy and e-mobility systems. I've been told that we will first play the video and then we will connect with them, since there seems to be like some connection problems. So let's play the video of Afef.
Good morning, everyone. We are proud today to present you the first Tunisian platform on microgrid that is based on a PV generation and distributed storage system that can be used for both grid-connected system and isolated areas. This platform, named SmartNest, a smart microgrid platform with an energy management system, is implemented in our National Engineering School of Tunis, ENI, in our research group lab in the frame of Med-EcoSuRe project. The platform can serve for many purposes. First, as training and capacity building equipment to enhance the cooperation between our university and the socio-economic operators, mainly those working on innovative solutions with renewable energy integration. For example, the STEC, our national energy provider, which is interested in such platform to test novel power electronics and renewable-based microgrids in urban and rural areas. Second, for academic activities, since many PhD and master students, as well as professors and researchers, are conducting their research on such topics and are interested in testing their fundamental findings on real microgrid platform. Third, for replication and scalability, because such microgrid can be easily replicated in other departments of our university or even in other universities, since one of the main goals of Med-EcoSuRe project is Mediterranean University to stand for a catalyst for a sustainable renovation. From a technical point of view, smartness has a capacity of around 15 kilowatt microgrid composed of a central system that you can see here with needed power electronics and electronic equipment that creates a local power system to feed 4 satellites. Each of these satellites is emulating a real house. The central system is connected to a PV generation system assured by 7 PV panels installed on the roof of this room and a central storage system with these 2.4 kilowatt-hour batteries. The central system can be connected to the grid, like as you see here, or operates in a standalone mode, guaranteeing an energy feeding to the 4 houses since it is equipped with a smart energy management system. So we have 4 houses, each of them is fed by its own decentralized 6 PV panels. The first house, House 1, has in addition its local storage battery that you can see here. This is the battery of the House 1. Each of these 4 houses is called prosumer since it can produce and consume electrical energy from its own production or from the smartness local grid. Each of these houses has 2 types of loads based on the level of necessity. First, the critical loads, named here backup, that have to be always fed for security reasons, for example, such as this lighting system in our case. The second are the non-critical loads, which will not operate in case of a problem on the local grid, like the home appliance system we have here. Smartness is monitored thanks to 2 online platforms. First is the Julia platform used to monitor the central system and the overall energy consumption, storage and production. The second one is SEMS Portal platform, which monitors each of the 4 houses' system consumption, storage and production. SEMS monitoring system is also available on the smartphones connected to smartness. Thank you for your attention.
Thank you, Afef. I don't know if I can, yeah, we can see you. We know that the connection didn't work very well today, but we managed to see the video. And thank you very much. I wanted to ask you, because you mentioned the SEMS and JUA platforms, so if I well understood, one is for managing the microgrid connection, and the other one is to manage how the microgrid is connected to the grid, to the national grid. Is it?
Yes, in fact, Julia is the company that the Gamco Energy company, this central system. And it has developed its own portal, which is the Julia portal, and we are using this Julia portal here to monitor and store the data in the cloud, the data corresponding to the energy transmitted in smartness in the cloud. On the other hand, SEMS portal is the GoodWe portal. So the GoodWe is the company that developed these inverters, these satellites, and their portal is used to monitor and store also the data corresponding to the energy transmitted in each of these satellites. We have 4 satellites, so 4 prosumers, and we can connect to SEMS portal via our computers or via our smartphones, in fact. And to see the transmitted energy consumption, storage, production, etc., in real time, and after we have access to the data, in fact.
Thank you very much, Afef. So let's go to the last step of our trip. So we are going today to Palestine to the An-Najah National University of Palestine, where we'll meet Fida Salameh, who is a senior electrical engineer with a broad experience in developing solar power plants. But today, she's not going to show us a plant, but rather a tree. So let's see in the video what this tree is about.
Hello, I'm Engineer Fida Salameh from An-Najah University. We are here at the site of solar tree, which was implemented at the front yard of the new campus of An-Najah University under the framework of Med-EcoSuRe project. The Med-EcoSuRe project has a major role in promoting the concept of renewable energy application in Palestinian University. And we at An-Najah University have installed many solar systems which contributed to reducing electricity consumption by 20% and also reducing the CO2 emission by 550 tons annually in order to increase the awareness among university students. And through Med-EcoSuRe project, we have implemented a solar umbrella system so that students can easily charge their mobile and laptops, which will increase their awareness of the importance of solar energy. The outdoor lighting of the garden has also been connected to this system in order to achieve the most benefit of solar tree. The solar tree has been installed with capacity about 3 kilowatts and produce approximately 15 kilowatt-hour per day to cover the needs of many students and to ensure the sufficient lighting for the outdoor garden of the university. The tree consists of 3 branches. Each is connected to a 4 solar panel. During the daytime, when the sunlight is sufficient to meet the load, the generated solar energy directly feeds this load. Any excess of solar energy is stored in battery. The result and lessons learned from the implementation of the solar tree will be shared with other campuses at the university to be able to replicate or scale up these projects. Thank you, European Union, and those in charge of ENI CBC MED program and MEDRIC, who is in charge of following up the implementation of the project, and for providing the opportunity to implement this project at the university and to be as a model for other Palestinian universities.
Thank you, Fida. I don't know if you are there, but if not, we are going to continue because we are a little bit tight of time.
Yes, I'm here.
Yeah, well, we managed to see the video. So, do you plan to build new solar trees or other kind of solar installation in the campus?
According to the high impact of installing the solar system in our university and through a Med-EcoSuRe project in our university, we have reduced the electricity by 20%. So the university is planning to replicate this pilot project and other integrated PV system in our sites, in other campuses of university, and also to transfer this idea to the other Palestinian university.
Thank you. So we have seen this, and I think that one of the ideas that we must get from this last connection is that solar panels must become part of our urban settings, of our landscapes, and we can integrate solar panels in a way that we will make our cities and the place where we live and where we move more sustainable, and we will have quick access to energy. So let's go with the last part of this session. And as you know, we are in the European Year of Youth, so we didn't want to miss the chance to tackle this issue. So today we are having here a person who is going to talk about what careers opportunities we have in the energy sector, since this is we all know that there is a big opportunity now, and we will need to develop a lot of things in the energy sector. So today we have Suha Ferchichi with a PhD in mechanical engineering, and who is a young researcher at the Mediterranean Renewable Energy Center in Tunisia, who will talk about career opportunities. Suha, the floor is yours.
Thank you. Can you hear me? Yes. Thank you very much for the introduction and for this opportunity to join the event. I chose to pursue a career in the energy sector actually when I was in my final year of engineering studies in Tunisia. And it started when I had to choose the topic for my graduation project as any other student. So for me, it was a tough choice between biomechanics and sustainable energy systems. So at that time, I consulted with some of my professors and family members, which led to go with sustainable energy systems as a focus for the next chapter of my academic and professional life. At that time, I was very much convinced of the simple yet very relevant idea that we live in an environment where everything, including our work, our culture, economy, etc., relies on the use of energy. So we can be involved in many, many ways, starting, for example, from the technical aspects, such as the design, consumption, and operation of these energy systems, until the aspects dealing with sustainable and socio-economic development when, for example, focusing on clean and affordable energy matters. Furthermore, along with the growth of the world population needs and also the comfort standards in all over the world, and in particular in some of the emerging countries, such as in Asia or Africa, the energy industry was growing very fast. And also the career path was getting higher, or opportunities were getting higher. And so this was a very much important aspect for me because I had to secure a job for myself also in the future. So this employment rate is growing and will continue to grow based on a report that was published by the International Renewable Energy Agency, ERENA, in 2021. So as you can see in these figures displayed in here, that among other technologies, energy efficiency is an important pillar of the energy transition and has employment, as stated in the report, particularly between 2020 and 2030, which is reaching above 45 million jobs by 2030, and renewables also will contribute with 39 million jobs. So throughout my career, I have been involved in EU-funded cooperation projects, which start since 2014, since 2014. And these projects address common challenges such as climate change mitigation and adaptation and socio-economic development. So among this project, I don't know if I have to go this way or, I know. Yes, okay. I don't know, this one? Okay, thank you. Okay, so among these projects, I can mention RECOOP, which stands for Renewable Electricity Cooperation, which is a project funded by the Framework Package 7 program. I can also mention CCAP for Sustainable Development Goals and Med-EcoSuRe, which was just presented by our partners now. And these projects dealt among, of course, other aspects, with the development of novel solutions and actions and strategies for the generation of electricity based on renewable sources, and also for the renovation of the public building stock, mainly in the Mediterranean area. So I would say that the big advantage of working on this type of projects and sector in particular is that you get to learn a lot of things at the same time, which contributes enormously in building your competencies, of course, compared to other types of jobs. And I would like also to add that the career growth pace is quite rapid. It's really rapid in this sector, and so this makes it much easier to access and fit in the global job market. I have also noticed that this sector involves a wide range of disciplines and of backgrounds, starting from engineering to architecture, economy, physics, chemistry, etc. And I have been working on these cooperation projects, including Med-EcoSuRe, CCAP, or RECOOP, and have been involved with these people, which turned out to be very essential for the successful implementation of the projects in question. So these are some photos that were taken while I was working on these cooperation projects and with members that I am still in contact with till date, which I particularly cherish. Okay. So I would say that overall energy is a sector where knowledge, technology, and even challenges are common all over the world, with, of course, some particularities in each country, depending on the natural resources available, on the legal framework, and the energy standards imposed. Also, this sector, in this sector, there are always opportunities to innovate, as the sustainable energy and clean affordable energy are quite of interest currently. And so I think, in my opinion, that the focus should be more on preferences and skills rather than on disciplines and background. So finally, based on my personal experience and seeing how things are rapidly changing and expanding in the energy industry, I can confidently say that this sector is offering and will continue to offer a vast range of career paths, especially for youth in Europe and outside, with plenty of choices and opportunity. And if I may conclude with a thought that my colleague Ines, which is sitting right there from MEDREC, to say that we can consider energy and culture as universal sectors by excellence, which we should target and take advantage of in a positive way, of course. Thank you for listening.
Wow. I think that was a wonderful pitch for the energy field. So, so who has not been convinced up until now is convinced now, I hope. And after seeing all of those wonderful projects, I think it was a very convincing demonstration of what can be done in terms of making our buildings resilient, and also in terms of reducing the emissions and reducing the energy use. You said something very important. There is energy efficiency, which short-term can really make a tremendous gain, and we really need it now with the winter also ahead of us. And then it needs to be combined with the renewable energies in all the various shapes and sizes and forms that we saw. I think we also heard about the very big importance of data and of digital and of the major opportunities this offers to us in terms of handling the energy, in terms of monitoring and measuring, and in terms of making sure that we use energy when it makes sense to use it, and that it is timely and adapted to the needs. So we do have a super opportunity now, because this is Fit for 55. There are major files on the table that are being revised and that are entering the final stages of negotiation. So I can only appeal to the policymakers, if there are some in the room perhaps, to really, really get this right. The technologies are available, it's all there. We need to just deploy it. We need to make sure that people know about it. And the framework must give the certainty also that is needed to deploy all of that. We need to stimulate renovations, building stock, super important. And we also heard not stop at heritage buildings, even there it is possible. We heard a lot of different examples. The minimum efficiency performance requirements that are being proposed are sending a right signal. So let's continue in this vein. We need staged and deep renovation to make this happen. We need to incentivize the public sector to really play a model role. And we heard all the examples. It is possible. Just it's all about information, education, making sure people know what they are talking, what they are hearing and what they are talking about. The skills to make it happen, I think your pitch couldn't have been clearer. We need the skills to make this happen and harness the potential of the digital solutions that are out there. There is a lot that can be done with digital, be it BIM, be it energy management systems, be it building automation and controls. There is a lot that can be done in that respect. And that will bring us also to consider not only the operational emissions, but the full life cycle emissions, and also the building material emissions at the end of the day, the embodied carbon and everything that goes with it. So we have a lot of opportunities. We have the right moment in time. We have a window open to act. Let's just get it done. And we heard it is possible. It's all out there. Let's just make it happen. And thanks a lot for organizing all of this. It was a great pleasure to work with all of you. I was very skeptical in the beginning that we would manage to get this all done in this short time, but we did. We did it, and all credits to you, Alejandro. You were very confident from the start. So thanks a lot to everybody for listening in. And I don't know if you want to say a few words to...
No, nothing else, just to thank to other projects who accepted this challenge to showcase their results here in Brussels, and we're happy to see that we are having results. Thank you for the Global Alliance also for accepting to this challenge as well. That was to showcase so many things in 90 minutes, but we made it, so great. Thank you very much to all of you for coming as well.
And go and visit the Global ABC's website for more information and join if you feel inspired, which I hope you do. Thank you.